Hello, this is Mrs. Boots, and in this lesson we're going to simplify, add, and subtract radicals. Now the simplifying we already reviewed a little bit when we did quadratic formula, but we only did square roots, right? Obviously this time we're going to add in the cube roots, so we're going to do a little bit of both for comparison. So remember, how do you do a square root, right? What multiplies to give me 1,200? Yeah, 1,200. It's easy. Anytime I see zeros at the end, I know it's divisible by a factor of 10. 2 zeros divisible by 100. Well, 12 can be broken down. So I can do square root 3, square root 4. 3 times 4 is 12. Then I have my 100. 100's a perfect square, so that's why I'm not breaking it down any further. What's the square root of 3? It's just square root 3. What's the square root of 4? 2. What's the square root of 100? 10. So we would write that as 2 times 10, which is 20. So the simplified radical would be 20 square root of 3. Now, in reality, you're not going to walk into a hardware store and say, I need a board that's 20 square root of 3 long. No. They'll look at you and kick you out. You plug it in, you get the decimal value. But for scientific, we're going to keep that square root of 3 because we don't want to round off and then have a rounding error. Okay, what do you do if there's a number already in front? You're going to multiply it. So it just drops down. My 50, now that's just 2 quarters, right? 25 cents, 20. So 25, the square root is 5. So now I have 3 times 5 times the square root of 2. 3 times 5 is 15. So 15 square root 2. Okay, that's my simplified radical. Now let's do a comparison. The square root of 64. Well, if I did factor tree, I'd know that that was 8 times 8, right? And 8 times 8 is 64. So the square root of 64 is just plain old 8. But then we get to this. What in the world do we do with this? Okay, well, let's do 8 times 8 again, right? We can do 8 times 8. Okay. But it's a cube root. Cube root means you'd have to have 3 of the same number. Or it's divisible by a perfect cube. Well, 8 can be broken down to 4 times 2. 4 is 2 times 2. So I have a set of 3 2's. And another set of 3 2's. So I can pull those out. So what is 2 times 2? Well, that's 4. So the cube root of 64 is 4. You're like, Mrs. Boots, I really don't think that's right. Try it backwards. In your calculator, if you did 4 to the 3rd power, check, do you get 64? Yes, you do. Just like if you plug in 8 squared and checked it, you would get 64. Okay? So now instead of looking for pairs, we're looking for a trio. Instead of 2 of the same number to pull it out, I need 3. If it were a 4th root, guess how many I would need? 4. The little number out in front of the radical indicates how many duplicates you need to pull it out. Okay? It tells you what you're looking for. Let's do example 4. And yes, the numbers tend to be bigger with these. So, evens, you typically start with dividing by 2. Odds, you divide by 3. I happen to know that 192 is divisible by 3. Okay, so I'm going to split this up into 3 and 64. Cool. Didn't we know something about 64? Yes. So if I take the cube root of each of these numbers, the cube root of 64 is 4. Well, what do we do with that 3 left over? The same thing you did if it was a square root. You just leave it underneath. The only difference is you do have to write the 3 with the radical right out front. That is your simplified answer. It's the exact same thing. It's the exact same thing you were doing before. Now let's look at 135. Well, it ends in a 5. If it ends in a 5, it's divisible by 5. So split it up. We have 5 and 27. 27. 27 is 3 times 3 times 3. Do I have a trio? Yes. So that means I can do the cube root of 5, cube root of 27. We know the cube root of 27 is 3. So this becomes 3 cube root 5. All right? Now let's do 40. Some of you are sitting there going, how do you keep up with all this? I'll give you a hint in a second. I really will. I promise. Okay. Or should I give you a hint right now? Let's give you a hint right now. You need to memorize a few things. If you don't know your perfect squares and perfect cubes, you can go into the calculator, and where it says y1, you can plug in x cubed. 0's easy, 1's easy, 2's 8, 3's 27, 4 is 64, 5 is 125, 6 is 216, and 7 is 343. To be honest, that's as far as I've got them memorized. Okay? But if you don't know your perfect cubes and you don't recognize them, you can always plug this into the calculator and find them. And that makes things a little bit easier. I'll leave that up there through the rest of the examples, okay? So let's look at 40. Does one of the numbers in this y column divide into 40? Yeah, 8 does, right? 8 goes into 40. So I can do a cube root of 8 and a cube root of 5, because 8 goes into 40 5 times. Well, we already know the cube root of 8, right? The cube root of 8 is 2. So this becomes 2 cube root of 5. I would highly recommend you memorize your perfect squares and your perfect cube. Addition and subtraction. Look at examples 7 through 10. All of them are addition and subtraction. What do you have to have in order to add or subtract the radicals? The number under the radical must be the same. It doesn't matter if it's a square root or if it's a cube root. They have to be the same every single time. If they're the same, I add and subtract the number in front. So I have negative 3 plus 2. Well, that's negative 1. And then you bring down your radical, which is square root 5. Notice the square root 5 part doesn't change, okay? It's just the numbers out front. So in example 8, all my numbers out front are 3's. One of them's negative, okay? Does that matter? No. I need the numbers under the radicals to be the same. Notice 12 and 20 can be broken down. So let's do that. So this would be a negative 3 times, I've got square root 4, square root 3. Okay? The second term can't be simplified, so I just write it down. Third term, what am I going to have? What makes 20? Right, 4 and 5. Now, I created a table of perfect squares for you to reference. Again, you can create this table by entering x squared into y1 and get all your perfect squares in there. Okay? So what can we take the square root of? Well, we can take the square root of our 4's, and we can simplify that. Okay, so I have negative 3 times, what's the square root of 4? Yeah, it's going to be a 2. But instead of skipping that step, I am going to write it out. So this would be 2 square root 3. That's a 3 square root 3. This becomes a 2 square root 5. Okay, when you multiply, you're only doing the outside numbers, right? We're only doing the outsides. So this becomes negative 6 square root 3 plus 3 square root 3 plus 6 square root 5. Yes, you could have skipped steps. You could have done the second 2 steps in your head. All of it in your head, okay? And if you're comfortable doing that and you're not going to make mistakes, go for it. Just double check yourself, okay? Now we have some like terms we can combine. Why can I not combine the last term? Yeah, 3, 3, 5. Nope, can't combine it. Only can combine the other two. Now remember, what do we combine? The numbers in front. Negative 6, positive 3 gives me negative 3. So I have negative 3 square root 3 plus 6 square root 5. That's it. That's simplified. Unless you approximate it by plugging it in a calculator and getting decimal values, this is the best you can do right now. And that's okay. All right, that's okay. Now, let's look at some examples with cubes. Really scary. So we're going to look at our cube table to break things down. I have 250. Is 250 divisible by any of these perfect cube numbers? Yes. It's divisible by 125. Okay, 125. So 8 times, I'm going to have a cube root. What's in there? 125. Well, how many times will 125 go into 250? Twice. So I have a cube root of a 2. Easy enough. Now let's do second term. Well, it's 2, so it's going to stay because the only thing we can divide that by is 1, and it's not going to change it. Now what about 16? What is 16 divisible by? Well, it's not going to be any of the big numbers, right? 8. So we're going to write this as the cube root of 8. And then how many times will 8 go into 16? Twice. Okay, so now if you'll notice, you have 2 things that you can actually take the cube roots of. All right? The cube root of 125 is 5. It lines up in the table. So I have 8 times 5 times the cube root of 2 plus 7 times the cube root of 2 minus 3 times cube root of 8 is 2 times the cube root of 2. Do my roots match? Yes, but I have to finish multiplying what's out front first. 8 times 5 is 40. That's just 7. And 3 times 2, that's going to be negative 6. Okay? So 40 plus 7 minus 6 is 41. So 41 cube root of 2. Now, for me personally, I have a tendency to combine these 2 steps and do them in my head. I'm writing it out so that you know what's going on, because if I don't read minds and I'm older than you, then I figure you don't read minds. If I'm wrong and you can read my mind, sure, then you can do all the steps, okay? Make sure that you write it all down the first few times so you don't miss anything, okay? Let's do example 10. Let's see what we got. Okay, well, the first thing I notice is the beautiful negative. No, we don't get i's. Yeah, okay? So I is equal to the square root of negative 1. The cube root of negative 1 is negative 1, okay? So I'm going to have that negative 3 out front times a cube root, we're going to split it up, of negative 1, and a cube root of 3. That cube root negative 1 is going to be simplified. Plus 2 times, big number, 192. Well, we did that number before, didn't we? Maybe that was a square root. Try just plain old 3. Divide 192 by 3. What do you get? Yeah, 64. Okay? So we have a cube root of 64 and a cube root of 3. Do you see a pattern? They're both 3's. Well, let's see if we got a 3 on this one. 3, 81. Well, it's divisible by 9. If it's divisible by 9, it's also divisible by 3. So we'd have the cube root, surprise, surprise, of 27 and the cube root of 3. Okay, let's simplify. Which ones can we take the cube root of? Negative 1, 64, 27. Okay? So what's the cube root of negative 1? Yeah, negative 1. What's the cube root of 64? 4. And the cube root of 27? 3. Just a plain old 3. Okay, got a little ahead of myself. Now let's multiply and simplify the numbers in front of the radicals. If we don't do that, then we're going to have a problem. Okay, so negative 3 and negative 1 gives me positive 3. 2 and 4 gives me 8. And 3 times 3 gives me 9. Do my radicals match? Yes. That's the cool part about teachers. Every now and then we give you easy problems. Okay, so I know I'm going to have a square root 3, or I'm sorry, cube root 3, but I have to add the numbers out front. So 9 plus 8 is 17. 17 plus 3 is 20. So I have 20 cube root of 3. This is simplified. So if I were programming this model into a computer, I wouldn't want to do this because it's going to cost the computer extra processing time every single time I have to run the program. I'm going to want to plug this into the computer. It simplifies, and that way I can move faster. In examples 11 and 12, we have variables. And a lot of students, if we don't mess up on the numbers, we mess up on the variables. Variables are actually easier. Isn't that neat? So I have 2 problems. Example 11, we have what kind of radical? Yeah, we have a square root. In example 12, what do we have? We have a cube root. Okay, so I'm going to show you how they're different and how they're the same. So a square root, I'm just going to put a little 2 out here to indicate that it's a square root. So for variables, what we do is we divide by the type of radical it is. So we have an x to the 4th and a y to the 5th. And we just said it's a square root. Square is 2, so I'm going to put 2 underneath each. So I'm dividing the exponent by the value of the radical. 4 divided by 2. Well, what is 4 divided by 2? Yeah, it's just 2, right? So we'd end up with an x squared. Well, do you agree? The square root of x to the 4th is x squared. Yes. But what do you do with the 5, right? How many times will 2 go into 5? Twice. Evenly, it goes in twice. But there's 1 left over. That's okay. What we do is we take that 1 and we leave it underneath the radical. So anything that's left over stays under the radical, just like with numbers. But all you have to do is divide to get there. So let's look at example 12. I have an a cubed, b to the 12, and c to the 5th. What is the value of this radical? Well, it's a cube root. So I'm going to divide by 3. Only the exponents. This only works for exponents. Cannot do this with coefficients, no whole numbers. So a is now to what power? Right? It's to the first power. B is to the fourth power, because 12 divided by 3 is 4. C, well, it goes in once, right? 3 will go into 5 once, but how many is left over? 2. Okay, so I still have the C, but the leftover stays, in which case the 2 C's that are left over. Do we need to write the exponents of 1? No, we don't. This is simplified. So anytime you have variables, divide by the value of the radical. So write that out. For variables, divide the exponent by the value of the radical. So if it was a fourth root, I would divide by 4. If it was a fifth root, I'd divide by 5. If it was a 10th root, crazy, I would divide by 10. Okay, every single time you divide the exponent by the value of the radical. And that's how you do the variables in simplifying them for radicals.